Hello everyone. Today my AIT concept video is on Planck's quantum hypothesis. Before entering into the topic, let me introduce myself. Myself M J Krishna, rule number of 2295180212 from the TBL department. Let's get into the topic. Today's topic: Introduction to the quantum hypothesis. So in the introduction, we see that Planck's hypothesis is the one of the most important discovery in the field of quantum mechanics, right? So it is the major discovery in quantum mechanics. Without these, quantum mechanics may be the incomplete. So in 1900s, Planck's quantum suggests that energy is not continuous, but rather it's made up of small packets called quanta. Planck's introduced this concept to explain the problem of black body radiation. Okay, which is the radiation emitted by the heated object, right? So this is the next, moving to the next slide. So another introduction to the Planck's quantum theory is Planck's quantum hypothesis states that energy of a proton is proportional to frequency. This means the higher frequency photons have more energy on the lower frequency photons. Planck's also introduced the constant H, also known as Planck's constant. Okay, to quantify the relation between the energy of photon and its frequency. So it's he cleared the energy of the photons with its frequency, right? Moving to the next slide. So let us know that what is the problem of the blackboard radiation. Okay, blackboard radiation. Okay, you can see this. Okay, in this slide, okay, we see the ultraviolet red cratoscope, also called as Rayleigh Jeans cataphos, was in a prediction of the late 19th century but early 20th century classic physics that an ideal black body at the thermal equilibrium would emit the unbounded quantity of energy as wavelength decreased into the ultraviolet range, right? So we in this slide we have seen that what is the problem with black body radiation. Okay, moving to the next slide. What is the relationship between the energy of frequency and Planck's constant? Hmm. Okay, we see the relation between frequency and its Planck's constant. Okay, the energy equation is equals to h mu. E represents the energy of photons, and H is the present represents the Planck's constant, which value equals to 6.62 into 10 power of minus 34 joules per second. And V is the mu represents the frequency, and the energy equation is the direct relationship between frequency and energy, because frequency increases, so does energy. Energy does this possible because H is a constant. So E is equals to H mu is the equation of the Planck's quantum theory, right? Move to the next slide. This development of quantum mechanics and its importance. Let us know the importance of the quantum mechanics day-to-day life, right? Quantum mechanics is the fundamental theory in physics that describes the behavior of matter and energy that atomic substance scale. It is a mathematical framework that is used to describe and predict behavior of the particles such as electrons, photons, and neutrons. And it is based off our modern understanding and its nature of atom molecules. Okay. This says about the development of quantum mechanics as periods goes on increasing. 19th century, 20th century has become a lot of changes in quantum mechanics. So let us see the application of quantum mechanics in the today's technology, right? The first wave of the quantum mechanic technologies gives us the transistor. Okay, first quantum mechanic technology is the transistor, and this on increasing, these devices become the foundation of the modern computers and digital communications. Other example of technology powered by the quantum mechanics include MRI scans. For example, MRI scans are used by the principle of the quantum mechanics, right? So by this, I want to conclude that Planck's quantum hypothesis bring the revolutionized of our understanding of our nature energy. And the matter is idea of energy is not a continuous, but it comes in a discrete pack of quantum and paved the way for development and development quantum mechanics, which is a transfer our understanding and universe has led to many important technologies advancement. By this Planck's constant, which is quantifies and relation between the energy of photons, frequency, and fundamental constant of the nature that has implications of the various fields of physics, including atomic and nuclear physics, solid states, and the particle states. So by this slide, I wanna thankful to giving the opportunity to presentation. Mhm.